Test, test. Okay. Hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stats and math at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the link in the description below. So now let's start our session. Alright. So the first question today is asking us, what is the arc of a circle? Okay, so let's copy down the question first. So what is an arc of a circle? Okay, so an arc is a part of the circumference of a circle or any curve. So now let's draw a circle. Okay. And then let's use pink, or let's just do this. And let's call this, there's a point A and point B. All right? Okay. So AB will be the arc of the circle. Oops. And also you can see it's a part of the circumference. So let's write the definition down. Definition. So an arc is a part of the circumference of a circle or any curve. Okay? Yep. So that's what arc is. And in terms of the length of an arc, it could be measured in two ways. So that would be the first point. Second point would be measurement. Yep. And there are two ways. So the first, we can measure in the arc length itself. So let's use the same graph. Let's call the center as O. And let's connect with A and B. And that's theta, and that's L. Okay. So the first way, we measuring the arc, measuring arc length itself. And also the second way is using the central angle. Yep. Okay, and so the formula for calculating arc length should be either L is equal to R times theta, where theta is in radians, or L is equal to R theta times pi over 180, where theta is in degree. In this case, theta is in degree, and theta is in radians. Okay? Yeah. So radians just means anything related to pi. So let's say 2 pi, 3 pi, 2 pi over 3. And for theta is in degrees, it just means like 30 degrees, 60 degrees, or 45 degrees, something like that. Okay. Yep. So I think that's all we got for this part. Yep. So let's leave a comment. Okay. So solution is correct. Well done. Okay, our second question today is asking us what is the, let's copy down the question, symmetric property of equality. Property of equality. Okay. So this property states that, let's write a keyword down. So if A is equal to B, then we will have B is equal to A, right? So we can interchange the sides of the equation, and this equation will still remain true. So we can interchange the sides of the equation, and the equation is still a true statement. Okay? So let's say if 1 plus 5, oh, let's say if so it's 1 plus 5 is equal to 6, then according to the property, 6 is also equal to 1 plus 5, right? So same thing. Let's say if 3 plus 2 is equal to 5, then we also have 5 is equal to 3 plus 2. And same thing applied to functions. Let me just... So let's say if we have y is equal to 2x to the exponent of 3 plus 6, then we can conclude that 2x to the exponent of 3 plus 6 is still equal to y. Yep. So as you can see, we interchange the sides of the equation, and the equation remains true. Okay? Yep. So I think that's all we have for this part. So let's leave a comment. So solution is correct. Well done. Okay, next we have how many quants are there in A cups? Okay, so whenever we come across a question asking us to convert something in one unit into another unit, we always need to think about the conversion factor. Okay, so first, the relationship between quants and cups are 1 quant is equal to 4 cups. And now thinking about the conversion factor, conversion factors, which is just 1 quant over 4 cups. right? And then we just need to do our calculation. So we have A cups from the question. So A cups times the conversion vector. So 1/4. And so 4 cups and 8 cups will cancel out and give us a 2. So 2 times 1, which give us 2 as our answer. Oh, and don't forget the units. Okay, so that will be our answer. And then now we can write our conclusion. So therefore, there are two quants and 8 cups. Okay, so that's all we got for this one. Let's leave a comment there. Solution is correct. We're done. Okay, so the next one is asking us what is AA theorem? Okay, so first let's recall the definition for this. So AA theorem definition is that if two angles and a non-included side of one triangle are congruent to other angles and a non-included side of a second triangle, then the triangle are congruent. I mean, then the two triangles are congruent. So let's write down the keyword. So if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle. Then we can conclude that triangles are congruent. So let's use a example to explain this. So let's say I got two triangles right here. So that's ABC. Okay, and I also have another triangle. Let's call this A bar, B bar, C bar. Okay, and okay. So in the figure above, segment AB and segment A bar, B bar are non-included sides of the two triangles. So first, let's write that down. So segment AB and segment A bar, B bar are non-included sides of two triangles. Okay. Oops. So let's label this. Okay. So we have the following condition, which are angle ABC and angle A bar, B bar, C bar are congruent. Okay, and angle ACB and angle A bar, C bar, B bar are congruent. And lastly, we have segment AB and segment A bar, B bar are congruent. So we can have two triangles ABC and A bar, B bar, C bar are congruent. By AAS property, or AAS theorem. Okay. Yep. So for So for the first sentence, it's referring to the first A, and the second sentence is referred to our second A, which is stand for angle, and the last sentence is stand for S, which is stand for sides. So therefore, we have our AAS theorem. Okay. Yeah. So I think that's all we got for this question. Let's leave a comment. Solution is correct. Okay, so next we have okay. So it's asking us what is the formula for the surface area of a triangular prism. Okay, so first let's draw a graph to see what a triangular prism looks like. Okay, so here is a triangle. Should be something look like this. Okay, should be something look like this. And let's just write down the keyword of the definition of triangular prism. So triangular prism is a three-dimensional shape. So it is a three-dimensional shape that has two base or the ends which are in the shape of triangle. So base are in shape of triangle, which are the yellow part in my graph. Okay, so these two yellow parts are triangle, and in between this end, or say these two triangles, are the three flat faces that are in the shape of a rectangle. So we said other faces are in shape of triangle. Oh, I mean rectangle. Yep. So the one at the front, the one at the back, and the one at the bottom. Okay, so this reflect faces that are in the shape of a triangle. Okay, so in terms of calculating the total surface of this triangular prism, it is just a combination of this area of the two bases and the area of the three faces. So first, let's write that down. So let's call it A surface area. Surface area is equal to the area of the two triangle bases plus the area of three rectangle faces. Let's call this faces. Okay. Yep. Okay. So we have to take note that the ends are triangular in shape. So we just need to use the formula of the area of calculating a triangle, which is given by, so let's set A base is equal to 1/2 times base times h. So let's call this base and the height denoted as h. Okay? So the area of one triangle will be 1/2 times b times h, right? But recall that we got two bases and they are both in shape of triangle. So therefore, we need to times the 2 as a n because we got one right here and another one right there, right? So since there are two ends of prism, we multiply the equation by 2. So therefore, 1/2 times 2 is equal to 1. So we got 1 times b times h, which give us b times h. Okay, so we're done with the base part. So now let's dealing with the faces, which they're rectangle part. Okay, so a rectangle this is equal to length times width, or in short we can write just L times W. And for the rectangular prism, the width of the two faces is equal on the side of the triangular ends. So both the width of the face at the bottom of the prism is equal to the base B of the triangular ends. So hence the area of the faces should be, let's write it here. So A faces is equal to L times S plus L times S plus L times B, right? So that is the front face, that is a back face, and that is a bottom face, okay? So by simplifying this, we will get 2LS plus LB. So now we just need to combining the area of bases and faces. So recall that we go BH for the base. So let's write down the area of the total. So this should be BH plus 2LS plus LB, where B are bases, H are height, L is the length. Yep. and add S is the size. Okay. Yep, so I think that's all we have for this one. Maybe I'll just add a little more detail so that S is the side of the triangular ends. Okay. Yep. So whenever we come across a, how do we say this, like a complicated 3D graph, we always think about of its component, like what makes to this 3D graph. So in this case, will be three rectangular faces and two triangular faces, and by combining this together, we will get our surface area. Okay. Okay, so let's leave a comment. Okay. So our next question is asking us the difference between point slope form and slope intercept form. Slope intercept form. Okay. So first, we know that both ways can be expressed through the the equation of the line can be expressed from both ways. Like you can either represent by point slope form or the slope intercept form. And so let's draw a table. Okay. So here will be the point slope, and that's gonna be slope intercept. Okay. So in terms of point slope, it is used when a point through which the line passes and the slope of the line is given. Okay, so let's write the keyword down. Used when a point through which the line passes and the slope of the line is given. Okay, so in contrary, slope intercept is used let's say used when the slope and y-intercept of the line is given. Okay, and so when we want to write the equation for point slope, it is given by y minus b is equal to m times x minus a, where AB is a point through the line passes and M is a slope. So M is the slope, AB are the point through line. Okay, and in terms of representing slope intercept form, we have y is equal to mx plus b, where still m is a slope and b is its y-intercept. Yeah. So that's all we got for this question. Let's leave a comment. Good job. Yeah. So I think that's all we have for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you would like to submit your own questions, please read the link in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew.